Hi guys, so this is section 5.2, still working with our exponents and radicals like we started last section. So the biggest thing here is really, whether you remember it or not, but we have a whole bunch of properties of exponents that you actually learned in Algebra 1. But let's just do a quick review of those. So you want to make sure these are in your notes and that we're going to practice them today, but you really want to become familiar with them. And like the only way you're going to become familiar with them is by practicing. So hopefully we can really pull together and understand all of these properties of exponents because they're really important. So let's remember product of powers. When I'm multiplying variables, my exponents add, check out the m plus n. When I divide variables, the exponents subtract. Okay, we need to remember these. These two are really common. Power of a power is when I have two exponents, a power to a power, they multiply. So here's where they multiply. When I have an exponent raised to another exponent. Power of a product is when I have a product, when I have multiplication of two variables, basically that exponent gets distributed to both terms in the product only when we're multiplying here. When I'm subtracting it or adding, it's not going to work that way. Only when I'm multiplying, it's a product, will I distribute that exponent. And it'll look like this. And then let's recall negative exponents. When we have a negative exponent, I basically make the entire term its reciprocal. So every whole number is over 1. So if I take the reciprocal of this, notice it's now 1 over a, my exponent now becomes positive. So this is something that we're going to use a lot in this lesson, and we might have actually used it in last lesson. So we really want to make sure we get a good grasp on it now. So let's just do an easy example, first example here. It says, let's rewrite this expression using the properties of exponents. So which one am I going to do here? I see I'm multiplying two variables. So when I'm multiplying two variables, that tells me I have to use product of powers, right? When I add my exponents together. Okay, so it's going to become x to the 3 plus 7, which is going to give me x to the 10. And that's all it is. Okay, that's a very easy one. Let's take a look at another one. So there's two we're actually going to use in this example. Just one in this example. Which property do you think we're going to use in this example? So I'm dividing variables here. Hopefully you notice that I have an a in my numerator and an a in my denominator. We can only simplify variables when they're common, right? Notice all of these properties, they're the same here, right? A and a are the same, a and a are the same. So let's first focus just on those a's, and we're going to use the quotient. Okay, that quotient of powers. And I'm going to rewrite a to the 25 over a cubed as a to the 25 minus 3 divided by b squared, because there's no reason to move that b squared, right? That b squared has to stay to the denominator. Nothing changed. Nothing told it to move anywhere. And then we can combine, we can simplify, right? 25 minus 3, that's going to give me 22. That's as simplified as we can get. Okay, awesome job. Let's take a look at another example. It's really all this lesson is on practicing these properties. Starting off simple, and if we were in class, you'd be like, does it get any harder? Oh, I missed that. Okay, here we go. Here's the next one. This one, let's take a look. Which property do you think we're going to use when I have variables with exponents and then another exponent on the outside? Okay, we're going to use really a combination of these two. We need to recall that when I have an exponent on the outside of a product, the exponent gets distributed to everything. So that's the first thing we need to remember, is that this 1/2 needs to get distributed to everything in the parentheses. But how it gets distributed, we need to remember power of a power. When I have an exponent raised to another exponent, we use multiplication. So that's what we have to remember here. Power of a power and power of a product, both of those come into play here. Ooh, lots of good stuff here. Let's start. So like I said, we're going to distribute that 1/2. When I distribute it, power of a power tells me we need to multiply. So it's going to be b squared to the 1/2, or times 1/2. And I can make that 2/1, right, to make the multiplication of fractions a little bit easier. And times c cubed to times 1/2, or c to the 3rd times 1/2, a whole number. I can make it a fraction with a denominator of 1. And now I just have to simplify these fractions. And we can take a look. So 2 times 1 gives me 2, 1 times 2 gives me 2. I'd have 2/2, or everything's really going to cancel here, and I'd be left with b to the 1st power, right? And then here, when I go straight across, I'll be left with 3/2. Something we learned last section is we really don't want to have a rational exponent. Okay, I don't want a rational exponent, so that's where we have to remember how to write it as a radical. So remember, it's like x to the, I don't know what letters we use, but if we used m, n, that's the same thing as n. My denominator becomes my index, and my numerator becomes my exponent. And that's what happened here. We don't want to have rational exponents. This is a much better form of our answer, which is why we rewrote it. My denominator became my index. Doesn't need to be written when it's a square, right? A 2. And my numerator became my exponent. That's that. Okay, let's take a look at another one I have here. Ooh, this one's a little bit trickier. So this one combines a whole bunch of properties as well. So what's the first thing we notice? First thing I notice is I have x's in my numerator and my denominator. So I know quotient of powers is going to come into play. Another thing I notice is I have this parenthesis, this big parenthesis with an exponent outside of it. So I'm going to need to use power of a product and distribute that 2/3 some point into everything in the parentheses. Which means then I need to remember when I do that, my exponents use multiplication. Okay, so let's see what we have. Quotient of powers, powers of powers, and power of a product there too. The first thing I did, and it doesn't matter the order that you do these in, the first thing I did though was I used quotient of powers. That's the first thing I did, and that's the step right here. I got rid of the fractions, right? We hate fractions. So let's get rid of this huge fraction. We know anytime there isn't an exponent, the secret exponent is a 1. So then I can rewrite x over x to the 1/2 as x to the 1 minus 1/2, using that quotient of powers property. When my variables are dividing, my exponents subtract. Nothing happened with that y cubed, so I left it the same. And my exponent of 2/3 is still outside of the entire product. So now I'll do some simplifying, right? 1 minus 1/2 gives me 1/2. And here is where we can use power of powers and power of a product, where when I see nothing else can be simplified on the inside, we're going to go ahead and distribute that 2/3 to my exponents in the parentheses. So now we're going to look like x to the 1/2 times 2/3 times y to the 3rd times 2/3. Okay, I can make this a fraction. And then I'm going to go ahead and simplify by multiplying my exponents together. So I'll have 1/2 times 2/3, my 2's cancel. I'll have x to the 1/3. And then y, here look, my 3's cancel, I'll have y squared. Same thing as before, I really do not want rational exponents. So I need to remember how to make 1/3, x to the 1/3. I have to write it as a radical. And so I'm going to take my denominator, make it my index, and my numerator, make it my exponent, which I really don't need in this case because it's a 1. Okay? Awesome job, guys. Like I said, the more we practice, the more we're going to get it. Looks like a lot, but the more you practice, it's going to help you remember these properties, and they're going to jump out a little bit more at you. So now you're going to try these. This is the practice for the day. Awesome job, guys. Thank you so much.